Hello, everyone. Welcome back to another episode, part of the Microsoft Sentinel in the Field series. Hope you all had a great holiday break. My name is Christopher Munoz, and as usual, I have my great colleague with me, Javier Soriano.
So welcome everyone, and today we're going to be talking about the new Microsoft Sentinel Deception Solution. And for that, we have our colleague Yossi Hasson. Welcome to the show.
Hi guys, Happy New Year. I'm very happy to be here.
Excellent. So first of all, can you talk to us about deception, both from a adversary perspective and also from a defender's perspective when it comes to IT security? What is deceptions and what is allocating decoys? And what has been the traditional approach when it comes to IT security in respect to deceptions?
Sure, Chris. So the deception techniques have been used for a long time. The whole idea is to spin up resources that are fake and act as a decoy for attackers. We also place additional monitoring on those resources. As these resources are not accessed under normal circumstances, we know that any attempt to access them is suspicious to have come from an attacker.
That sounds very good, Yossi, but I'm guessing that there's a cost associated with that, right? So because at the end, you need to have servers that are running, that need to be maintained. And of course, you need to also make that environment to look real and attractive for the attacker, which might not always be easy, right?
Of course, yes. So those are challenges that deception techniques have had traditionally. This is the case of honeypots, which normally require compute resources to be running and maintained. But we think that we actually have tackled those challenges in this new solution.
Yeah, can you tell us a bit more of how you have actually overcome or you're rectifying those different challenges?
Well, so instead of spinning up compute resources to lure those attackers, we have used honey tokens. Honey tokens are basically items in our IT environment that looks very attractive to an attacker, but are just pieces of information that are very low cost to create and maintain. In our particular implementation, these are hosted in an Azure Key Vault, which is a highly sensitive resource designed to protect objects that are of very high value to an attacker, such as passwords, connection strings, and cryptographic keys, which can then be used to perform privilege escalation or lateral movement.
You know what comes now, right? Demo time, please.
Sure.
Demo time.
Let's dive right in. Thank you, Javier. Let's start the demo part of this session. So I actually want to start from showing the value of the solution, not the deployment part of it. We'll get to deployment in the end. And I'll start from showing you a key vault that I created just for this demo, Honey Tokens Key Vault demo number 3. And as you see, there are actually 4 different keys in this key vault. One of them is a honey token key that was planted as part of the solution deployment. Can you spot this key, this honey token key?
No,
it's almost impossible. Yeah, it's almost impossible. It's actually impossible because the keys were created, the honey token keys were created based on the naming of the keys that the customers are usually using, and based on some other keywords that you will see later on how you set them, how you configure them. Anyway, I know that prod key number 7 is the honey token key, so let's try and actually trigger an incident of an access to a honey token, and we'll see how it works. So I'm clicking the prod key number 7 here, and I will also download it, getting into the key. And I download the public key. And this action should trigger actually an event, an incident in Azure Sentinel. But before we look at the incident, I want to show you a few more things. I want to show you the analytic rules that are deployed as a part of this solution. So there are actually 3 rules that are automatically deployed. The first one, 2 of them are actually looking for the access to the secrets and keys themselves. So one is for secrets and the other is for keys. And the third one is actually monitoring that no one has disabled the sending of the logs from the key vaults to the log analytics workspace, so we can make sure that we don't miss any logs and any attempts to access those honeycombs. Those analytic rules are working based on a watch list. So that's also another thing that is installed as a part of the solution, this watch list. And if we'll have a brief look on the watch list itself, so it actually shows us all of the honey tokens that were created and deployed automatically as part of the capabilities of this solution. It's important to understand that we are taking into consideration that the resource owners, for example, the key vault owner, can be compromised by adversaries. They are less secure than the SOC engineers and the SOC analysts. And that means that this watch list is actually visible and accessible only for the users of the SOC, which are much more secure and has less probability to be compromised.
Okay, so just one question. So at the end, the solution itself, it deploys the different analytic rules. It deploys the keys in the key vault, is that right? And also the watch list.
Correct. Correct. It also deploys some workbooks that helps the deployment of the key vault, of the keys, the honey token keys themselves, and another workbook that helps you investigate incidents, and we'll also see it in the demo very soon.
Cool.
Definitely. And just to level set real quick, what data connectors are required for this solution to actually work?
Sure. Great question, Chris. So today, as we are monitoring key vaults, we need two data connectors to be enabled and sending logs to the log analytics workspace. The first one is the key vault data connector itself, and the other one is the Azure Diagnostics data connector that will help us understand if someone disabled the logging of the key vault itself.
Excellent, excellent.
Okay, so let's see the incident that was actually triggered based on our last attempt to download the fake token key. So you know what, let's refresh and see. Yeah, that's the latest one. So number 18 here, incident number 18, that's the incident that was triggered due to the access to this fake key. And let's have a look at the details of the incident. I just prepared that on another tab. And we can see a lot of interesting details right here in Sentinel. We'll see more in the investigation workbook. But right here we see on the timeline that there was actually this access to this honey token key. We see also which entities were involved in this alert, the user, the key vault that was accessed, and so on. And very interestingly, we can also see the name of the honey token itself that was accessed and which operations were performed, key get and key list versions. So as I say, in addition to just having a brief look about the incident here, we can also use or open a workbook that is also deployed as a part of this solution. The workbook is called Honey Tokens Incidents. As I said, it's automatically deployed when you deploy the solution. We'll see how the solution deployment works in a moment. And it shows actually just the deception-related incidents and provides a lot of more info and more investigation capabilities to those incidents. So for example, if we look at this one, incident number 18, sorry, didn't mean to jump to another screen. If we look at incident number 18 here, and we'll, first of all, we see all of the different incidents and on which key vaults they happened and which honey token names were accessed, which operations were performed. If we go to a specific one, we can see all of the different entities that were involved in this alert, the resource, the IP, account, and so on. And if we actually click one of those resources, we can also see all of the adjacent or other interesting events and audits and data that was collected by Sentinel around this entity, right? So we see different activities and operations like secret list, secret get, vault get, key list, and so on. And if we click one of those, let's say key get, we can see also all of the different detailed logging of the activities around this operation that this IP address did. And very easily from the same screen, we can also open the entity page for that entity in Sentinel. So I just opened it in another tab to make it quicker for us. But here we actually can continue the investigation and look what activities this IP address did in addition to the deception attempts attempts to access those honey tokens. In this case, in the demo, we just have the key vault access alerts and activities, but in real life, you will have a lot of different activities that will be monitored and viewed over here.
Very good stuff.
So this is awesome, Yossi. So aside from actually having the ability to implement the solution, we also have an interactive workbook that provides as an entry point for investigation. And then from there, we also have data pivot points to bring it back to the incident pane as well, correct?
Correct. Yeah, that's how it works.
Can you show us, Yossi, how it's deployed?
Yeah, of course. So the way to deploy this solution is like any other solutions in Sentinel. So we do have the notion of Content Hub. That's a preview feature in Sentinel, which, let me clear the filter here for a moment, which includes today 103 different solutions that you can deploy to Sentinel. Solution contains all of the elements required to run some solutions. So connectors, analytic rules, threat hunting queries, workbooks, and so on. In our case, we have a solution called Deception Honey Tokens. By the way, this solution is still in public preview, and we are looking to GA it later in this semester, and it will have some modifications and changes, but that's how it will work generally. So if you go to that solution and install it, and then you'll hit create, you will go through a wizard asking you to fill some details, which workspace you want the solution to be deployed on. You will need to provide some details for the function apps that are deployed as part of the solution and some client IDs and so on. You will have to provide some names for the workbooks and an email address for the SOC manager that will get some alerts along the way. You have to, well, here you don't have to provide anything. That's just a list of analytic rules that are deployed, the name of the watch list. And then you'll have to provide some namings for the playbooks that are part of the solution. Okay, so the next step in the wizard is the Azure functions. So you have to define here some settings for the function that is actually deploying the honey tokens in the key vaults. And interestingly, you can see that you have a few different interesting settings here. You can actually define the keywords that this function will use to create the fake keys, both for keys and for secrets. So just a way to help the function create more attractive names for those fake keys to lure the attackers. You can also define something that we call additional honey token probability, which means, which actually influences what are the chances that we'll deploy more than one honey token in each of your key vaults. Next, we give you some recommendation on post-deployment, and it's mainly a recommendation around how to deploy the honey tokens to the different key vaults. So the main challenge here is that the resource owners of the key vaults are usually not the SOC engineers, and the SOC engineers will not have the permissions to create honey tokens in the key vaults. So we have created a workbook that I'll show you in a moment that you can send to the key vault owners to ask them to deploy automatically those honey tokens using this workbook. And there is another way that we are recommending here to actually help with sending out those workbooks, which is a recommendation, a custom recommendation in Defender for Cloud that shows the resource owners if they are not in line with the policy around deployment of honey tokens, and recommends them to use the workbook that I'll just show you to deploy the fake keys. So that's
Yossi, you didn't explain much about the playbooks. Can you tell us a little bit what they do and what they're about?
Sure, of course. So those playbooks are actually used in this workbook. So I'll get very quickly to them. So this workbook is the tool that should be used by the resource owners, by the key vault owners, to deploy the honey token keys and secrets to their key vaults. So this is something that we need the SOC engineer to send to those resource owners. And when they open it, to send a link to it, right? And when they open it, they will see this list, right? So they will see here a list of all of the key vaults that they have permissions to view and to change. And for each of those key vaults, they will see if the key vault is monitored by the SOC. What does it mean that the key vault is monitored by the SOC? It means that there was a honey token key created and implemented in this key vault, and the name of this key vault, of this key, this honey token, the details about it, were entered into the watch list that the analytic rules are using in Sentinel to detect access to those honey tokens. As you see, in our case, we have actually 34 key vaults that this user, myself in this case, have permission to see. They can be key vaults across all of the tenants, across different subscriptions, and 33 of them are monitored. One of them is actually not monitored. That's the last one here. We called it unmonitored key vault just for demo purposes. And the resource owner should actually deploy a key vault also there. The first time the resource owner will open that, he will see that all of his key vaults are with an X here. All of them are not monitored by the SOC, and then he will have to take an action. He can either deploy at scale the honey tokens to all the key vaults, and that's a process that the guided process that he should follow. And this guided process actually uses the logic apps that we've just seen before, the playbooks that we've just seen before. So there are three main steps. The first step is to actually enable the user in the access policy of all of those key vaults. That playbook automates that action. When you click here, you actually run this playbook. And the other part is actually deploying the honey tokens themselves. So actually deciding what will be their name and creating them in the key vault. And that is also eventually created by the playbook and the function app that we've seen before. And eventually you want to disable your user access to the policy to make sure you don't do any mistakes later on. So this process will deploy to all of the key vaults here. But if you want to deploy to a specific key vault, let's say I want to deploy only to this one, I can actually click on that key vault and then run over this process, again, a guided process, to deploy on a specific key vault.
Excellent.
Let's have also a quick look in the recommendations, the custom recommendations that can be deployed on Defender for Cloud. So as a part of the deployment, we are guiding you on how to deploy a custom recommendation to a Defender for Cloud that will actually allow the resource owners to understand what is their situation when it comes to the key vault honey tokens. So in this case, as we've seen in the workbook, we have this custom recommendation here, and one out of the 34 Azure resources is not healthy. And if we go to the details, we'll actually see that the one that is unhealthy is the unmonitored key vault that I just talked to you about. We didn't deploy a honey token over there, and all of the rest are healthy, out of the other 33. What's important in this step is actually to provide the key vault owner, the resource owner, remediation steps. And in this case, the remediation step is to click here to install the honey tokens, and that will actually open for him the same workbook that we've seen before. And afterwards, he will need to actually put a note on the key vault itself that it was reviewed and now it should be compliant with the policy of the deception or the honey tokens solution in Sentinel.
Very good. Any other questions, Chris?
Yeah, so actually I definitely have a question. So, we're definitely working on extending the solution when it comes to deception. Yossi, what other future plans do we have for the solution?
Great question, Chris. So first of all, I think what we would want to do to the GA later in this semester is to make the deployment and monitoring and management of the solution much easier and less complex. The process now is a bit tedious. We understand that, and we'll make it with much less friction. And the other, even more important thing is to cover more and additional resources as honey tokens. So today we're supporting only Key Vault, which is a very important Azure resource, but we want to also deploy or implement support for storage and SQL already in this semester. Storage is very important because it will help you, our customers, to detect very early ransomware attacks. And when we talk about the SQL solution, the honey tokens tables or fake tables or fake rows in tables, this will actually allow us to showcase some other important capabilities of deception solutions. The first of them is the creating dynamic honey tokens. So we are planning to actually have those tables change their data over the time, so they will seem as real tables to those potential attackers. And another cool thing that we want to create is to implement the concept of breadcrumbs, which is very important in deception, which means that we want to actually create a higher confidence incidents or alerts when we see an attacker that actually picks up a token, accesses a token, and then tries to use it to access another resource, another fake resource in the environment, or even real resource. In this case, it will be a key vault, a key that is taken, that is accessed by the attacker, and then he uses the same key to try and access the SQL table or any other resource that need the key to be accessed to.
Wow, super good use case, that one. Really like it. Great. So thank you so much, Yossi, for coming to the show and talking to us about the new deception solution. Thanks a lot. Any last comments from your side?
Sure. Thanks, Javier. Thanks, Cris, for having me. It was a real pleasure showing the solution here and talking about our plans and our roadmap. I do ask you, our audience, our potential customers, to provide feedback, to let us know what you think about the solution. Try it. It's very easy to deploy the solution directly from the Content Hub. So try it, play with it, test it. Let us know how it works for you. And let us know what you want to see in the future in this solution, which other resources you want to be protected by that solution, which other capabilities of investigation, response, and so on you would want to have as a part of the solution. And we'll be very happy to put them in our plans and our roadmap.
Excellent. Thank you so much, Yossi, for being a great guest part of our show to talk about the Microsoft Sentinel out-of-the-box deception solution. With that being said, thank you all, and we'll catch you on the next episode. Thank you.
Thank you.
Thanks.